my name is Sarah McKillman, and this is my Cap 2 presentation on the fate of lactate. So, for this presentation, we're going to be going over the diagram on the left, which is the skeletal muscle creating energy to the liver in order for us to work out. So, the major steps of this pathway is glycolysis, lactate dehydrogenase, monocarboxylate transport, and the gluconeogenesis. So we're going to go ahead and start with glucose. So like we did for the last presentation where we talked about how we get ATP, we're going to start off through glycolysis. So during glycolysis, you're going to get 2-pyruvate, your NAD plus turns into NADH, and you also create 2-ATP. But the only problem is we can't enter the citric acid cycle because we're going through with no oxygen. So that means we're starting with an anaerobic process. So because of this, we have to go through a process known as lactate dehydrogenase. So during the lactate dehydrogenase, the pyruvate goes into this process and you're going to start getting lactic acid. Well, the skeletal muscle does not want lactic acid, so we have to get it out somehow. During this process as well, you also get a hydrogen ion, and the NADH turns back to NAD+. So, as I said, we have to remove this lactic acid somehow. So that means we have to go through the blood. So through this process, we have to go through what is called a monocarboxylate transporter, which is also known as MCT. So as we go through, the lactate gets converted into the blood, which also converts the hydrogen ion in the blood as well. So because the blood's buffering, the hydrogen ion doesn't become acidic, and also produces carbon dioxide, which can be exhaled out. So, then, in order to get to the liver, we have to go through the MCT transport, which goes back to lactate dehydrogenase. So the steps literally go backwards. So what happens is we go into gluconeogenesis side of it because we're recycling the lactate and turning it back into glucose. So as we're doing that, we take the lactate, turn it back into pyruvate, and then we're able to get glucose back. Well, because this process takes so long, it takes up 6 ATPs, so that's why it has -6 ATPs per glucose. So through this process, it's a long, slow process in order to get back to glucose. So as we move forward, how do the pathways are affected by exercise? So when performing intense exercises, we do need energy, which is ATP. Well, as I stated before, it's hard to get ATP through this process of lactate because it's so slow. So when there's no oxygen present, you get lactic acid within the muscles. Well, as I said before, you don't want lactic acid in the muscles because it could cause damage to them. So as the body converts lactate back to stored sugars following intense exercises, your body is busy replacing the oxygen it has lost. So the body produces energy via lactate only after it can no longer produce oxygen. So because of that, as you work out, lactic acid increases in the muscles that are performing the workout. So during this process, you're getting lactic acid in the muscles, and as I said before, the muscles do not want it. As we continue on, how do lactate and lactic acid differ? Well, according to the article, What is the Difference Between Lactic Acid and Lactate by Andreas Sepsids, who defines lactic acid is produced by your body in response to anaerobic exercise, serves as fuel for the muscles and delays fatigue and prevents injury. Lactic acid contains one additional proton. So as you look at the diagram on the left, lactic acid is the first one. So as you can see, it has an extra ion instead of lactate. So because of this, lactate, in order to become lactic acid, you must be able to donate, or in order for a lactic acid to become lactate, it has to donate the ion that way because it's different chemically. So when lactic is used metabolically, so lactate is actually the signal for muscle fatigue. And if you don't know what muscle fatigue is, according to the article Effects of Lactate Accumulation During Exercise by Hideaki Ishu and Yusuko Nidishia, they define muscle fatigue in human performance as any exercise-induced decrease in maximal voluntary force or power produced by a muscle or a muscle group. So let's say I'm working out with this 2-pound weight. I'm going to keep working out with it, but then all of a sudden my muscles start to burn and they start to get tired. This is the lactate signaling that you're starting to become muscle fatigued, okay? So the consequences are an increase in acidity of the muscle cells along with disruptions of other metabolites. Muscles cannot perform in acidic environments. Like I said earlier, the muscles do not want lactic acid in them. That's why we try to turn it back into energy. The Cori cycle helps to it as a natural defense in order to prevent damage in the body. So as the levels increase, it reduces the muscle ability to exert the force needed to complete the workout. The burning sensation, like I said before. So as you're working out, you're going to get that burning sensation that you need to stop. After anaerobic exercises, the body starts to produce sugar again. So factors that work at a cellular level that can cause exercise sensation. So sensation is defined as stopping. So what could possibly stop you from doing exercise at a cellular level? Well, my answer is trauma. So a good example of that is fibromyalgia. So fibromyalgia is a constant pain across your body that goes on for more than 3 months. So when you're in constant pain, you're not going to want to exercise. So this fibromyalgia happens within the body, which creates you to stop exercising. So in conclusion, skeletal muscles and the livers work together to create a system so our bodies don't become damaged. Lactic acid does not contribute to muscle soreness. So in my previous presentation, I was wrong about how lactic acid causes soreness. The only thing that lactate does is warns you when you're working out, that burning sensation. It helps you to stop and warns you about muscle fatigue so you don't damage your muscle. The body is definitely a well-oiled machine because it was able to create this process in order to help us from damaging our muscles during exercise. So thank you for watching. Here are the resources I used during my presentation, and thank you very much for watching.